Hello everyone, what's up? And welcome back to my world of physics. Ankit sir, the physicist here. Now, we are going to focus on a very important and on-demand topic, that is electricity. Now, we are going to be very precise and exam-centered and create a video which would revise the entire concept of electricity for you. So stay tuned till the very end, and by the end of this lecture, you will get a formula list and important terms and concepts from this chapter. So just by seeing this video, all the concepts of electricity will be done for your exams. So stay tuned till the very end. Now let us start with electricity. So electricity, the basic term electric current. In this, current means flow. You all must be familiar with the term water current means water flow. The water current was too strong or the wind current was too strong. So now in electricity or electric current, what flows? So electric charges flow. The flow of electric charges is known as electric current. We will be seeing the definition of electric current. A one-line definition says the rate of flow of electric charge. So electric current is rate of means we divide by time. What? Charge. So rate of flow of electric charge is known as electric current. But a textual definition goes like electric current is defined as charge passing through a conductor in unit time. Same meaning but different words. So electric current is defined as the charges passing through a conductor in unit time. So this is the conductor. We will see the surface area, the cross sectional area, and through this area how many charges pass through it every second. The unit time will be second. That will be the amount of electric current. So from this we can take out the formula electric current is charge upon time. So electric current generally denoted by I, charge which is denoted by Q upon time T. So I will be Q upon T, and the SI unit of current is ampere, named after the scientist ampere. It is generally denoted by capital A. Now we will be defining what is 1 ampere. Now, as we all saw the formula that I is equal to Q by T, matlab current is charge upon time, we'll be seeing the units of it. Current ka unit, that is ampere, charge ka unit is coulomb, and time ka unit is second. So 1 ampere is 1 coulomb upon 1 second. Now we have to write this in words to define 1 ampere. So we can say 1 ampere current is said to flow through a conductor, या flow in a conductor if 1 coulomb charge flows through it every second. 1 एम्पियर करंट तब होगा जब 1 कूलम का चार्ज वो कंडक्टर से हर एक सेकंड फ्लो होगा. Simple. Now we'll be seeing how does the current flow in a conductor. We have a conductor. Now in this conductor we have atoms and molecules which are vibrating at their places, and then there are free electrons. As metals only have these free electrons, metals are known as good conductors of electricity. So as you can see, whenever current is not flowing or whenever potential difference is not applied, these free electrons are bouncing off randomly here and there. Now, as soon as we connect a battery, a potential difference is generated. The one side of the battery will be positive, one side will be negative. And then these negatively charged electrons will start moving towards the positive side. And this is how the current flows. Now, as you all can see, the electrons are moving from negative to positive. From negative to positive. So the flow of electron is from negative to positive terminal. Whereas the current, or also known as conventional current, flows in the exactly opposite direction. That is, current always flows from positive to negative. That is, from high potential to low potential. This is the very important concept, and it will also be used in magnetism. So, if you don't get a direct question from this concept, but you have to be familiar with this concept. Now, the next important term, potential difference. Potential difference. As we all have seen, the water always flows from higher potential to lower potential. Not just water, I would say everything flows from higher potential to lower potential. Like wind flows from high pressure to low pressure. Now, we can't just create a potential difference in a conductor by tilting it. So, what we will do, we will connect a battery or a cell. So the function of a battery or a cell is to create potential difference, and once the potential difference is created, current will flow through it. So this is the symbol of battery, a bigger line and a smaller line. The bigger line indicates positive terminal, whereas the smaller line indicates the negative terminal. That is positive higher potential, negative lower potential. That is why we say current flows from positive to negative, or we can also say from higher potential to lower potential. Now, to define potential difference, we say that potential difference, the electric potential difference between 2 points in an electric circuit carrying some current, is the work done to move a unit charge from one point to other. Now, the important terms over here are work done and the charge. So, potential difference is having two important terms which can be put in the formula. So potential difference is work done upon charge, work by charge. So potential difference, which is denoted by V, work done W upon charge Q. So V is W upon Q. And the SI unit of potential difference is volt, named after scientist Volta. Now, the next very important concept is Ohm's law. So there was a scientist named Ohm who gave this concept, and this is very important concept, because definitely, like, straight statement can come, or concept based on Ohm's law can come, question based on this concept. Like in this, you can see we have connected an ammeter in a circuit, and as the current passes, the ammeter shows the arrow to 100 ampere. Now, if I increase the potential difference, means if I add one more battery, my potential difference will increase. Now let's see what happens with the current. As you all can see, the current also has increased. So from this, we can draw a conclusion that if potential difference increases, the current also increases. So when one increases, the second one is also increasing. They both are directly proportional. So Ohm's law statement goes like this. The potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. The physical condition of the conductor should remain the same. Now, everyone, potential difference directly proportional to current. V is directly proportional to I. Similarly, the next two steps will be putting a constant by removing the proportional sign. So we get V as Ki. The constant is nothing but also known as resistant. So we get a formula V is equal to IR, where R is the resistance, and as it was given by a scientist called Ohm, its SI unit is Ohm. Now this resistance depends on four factors. ये चार फैक्टर पे डिपेंड करता है रेजिस्टेंस. LAMT. L, length, A, area of cross section, M material, and T the temperature. So if any of the factor changes, the resistance will also change. So this is one of the very important concept, and the formula which is important is V is equal to IR, where V is potential difference, I is current, and R is the resistance. Now the next important term will be resistivity. So as we saw, the resistance depends on four factors. These factors help us to derive resistivity. Now, the very first factor we saw was length. So, we all know that length is directly proportional to resistance. How? See, if my length increases, the number of atoms and molecules increases, so will my resistance increase. Now, we can write it mathematically as R is directly proportional to length. जितना ज़्यादा लेंथ होगा उतना ज़्यादा रेजिस्टेंस होगा, जितना कम लेंथ उतना कम रेजिस्टेंस. Moving ahead, area of cross section, the circular area. So if the area is small, less number of electrons will move, and if I increase the area, more number of electrons can move. So if area increases, resistance decreases, and if area decreases, resistance increases. So they both are inversely proportional to each other. We say R is inversely, matlab 1 upon A. So R is proportional to 1 by A. Combining both of them, I can write R is proportional to length upon area. As we all know, proportional sign cannot be used in formulas. To remove this and convert it into equal to, I would have to multiply a constant. The constant which we multiply over here is resistivity, which is denoted by rho. So resistivity is nothing but rho. So R is rho into L upon A, means resistance is equal to rho, that is resistivity, into length upon area. And the SI unit of resistivity is ohm meter. Ohm into meter, that is ohm meter. Resistivity is a characteristic property, means every material has a specific resistivity. तो resistivity हर एक material का fixed constant है. So that is why it is also known as a characteristic property. Next, we'll be seeing how are the resistances connected. Resistance can be connected in two ways, that is a series and parallel. We will be deriving and understanding the concept of series first and then parallel. So now, resistances in series means the resistances are connected in a line. So these are the three resistances. For simplicity, I will name it as R1, R2 and R3, and I will connect all of them in series, means in a line. Now, to complete the circuit, I will connect them to a battery, a switch or a key, and an ammeter. And as soon as I switch on the key or switch on the switch, the current flows from positive to negative, that is high potential to low potential. You all can see the current flowing is same. The current is not getting divided. So resistors are getting same I. The I flowing is same. It is not getting divided. So a very important concept, important point to remember, current is same. A same current is flowing in series. Now to measure this, we have connected an ammeter, but we can't connect a voltmeter in series, so we will connect them in parallel. So the voltmeter V1 will be the value at R1, V2, R2, V3, R3. Like the total potential difference will be summation of all of them. So I get my first equation as total V, total potential difference, is V1 plus V2 plus V3. This is my equation number 1. Now we know that according to Ohm's law, V is IR. So here I will write V as I into RS. RS indicates the resistance in series. Yeah, I would say total resistance in series, also known as effective resistance in series. मतलब पूरा series का resistance को RS से define करते हैं. So resistance in series is RS. Now V1, that is potential difference at resistance 1, will be I into R1. Similarly V2 will be I into R2 and V3 will be I into R3. Now we all can see we have got the values, all the values of equation 1. So I will substitute this in equation number 1 and I get IRS is IR1 plus IR2 plus IR3. As I said, same current flows. So I is same, I is constant. We can take I outside and the II will get cancelled on LHS and RHS. So the final formula which we get is RS, resistance in series, is equal to R1 plus R2 plus R3. Now as we have only 3 resistors, it is going till R3. If we have 4, it will go till R4. If we have 5 resistance, till R5. So similarly, if we have n number of resistance, we say it will go till Rn. So this will be our final formula, that is Rs is R1 plus R2 plus R3 till Rn, means till number of resistances we have. Now after series we are going to see resistances, what will happen to them if we connect them in parallel. Now parallel means one above the other, parallel lines, like just like parallel lines. So here we have connected R1, R2 and R3 in parallel. Now to complete the circuit, a battery, switch and ammeter is connected. So from here I would like to add one more concept, that ammeter is always connected in series, but the voltmeter is always connected in parallel. Ammeter always in series and voltmeter always in parallel. Now you can see, as we turn on the switch, the current will start flowing from positive terminal to negative terminal. But as you can see at point C, the current will have 3 paths to go. So the current will get divided into 3 parts. So unlike in series, in parallel, current will get distributed. Same current will not flow. So in parallel, current is not the same. Current gets distributed. So there will be a part of current going in R1, part of current going in R2 and a part of current going in R3. So we will connect 3 more ammeters and we get a value of I1, I2 and I3. Now after that, we all can see they are connecting back at point D. So we can measure potential difference between these 2 points, that is C and D. So that is why we are connected the voltmeter in parallel from point C and point D. Now next step, as well can see I1, I2 and I3 is there. So total current I is the summation of I1 plus I2 plus I3. Equation number 1, similar steps as series. We will be using Ohm's law. Now V is equal to IR. So therefore I will be equal to V upon R. Here I will be writing RP because RP represents effective resistance in parallel. Yeah, total resistance in parallel. Similarly, I1 will be V upon R1, I2 will be V by R2 and I3 will be V by R3. Now same next steps, I will substitute these values in equation number 1. Now if we substitute this value in equation number 1, we get V upon Rp equal to V upon R1 plus V upon R2 plus V upon R3. Now, as we saw that current is not the same in parallel, but the potential difference is same. So we will be taking potential difference V as common. And as V is there on both the sides, V will get cancelled and we will be left with 1 upon Rp will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And similarly, if we have values till Rn, n number of resistors, it will be till Rn. Like if we have 10 resistors, it will be till R10. If we have 20, it will be till R20. So here we have a formula for resistors in parallel. Next, we are going to see the heating effect of electric current, usually used in all the heating devices like heaters, the iron, the geysers, and many more. Now, what is this heating effect of electric current? So, it can be divided into three simple points. First point, when current is flowing through a circuit, a heat energy is generated in the conductor, and this is nothing but known as heating effect of electric current. Now, why the heat is generated? Because as we saw, the free electrons are colliding with the atoms and molecules. So whenever there is this collision, it generates heat. And this heat is then utilized by the devices like heater, iron, and bulb. Now, everyone, the more the resistance, more will be the heat. And this concept we use in heating effect of electric current. Now we will derive a formula for heating effect of electric current. For that we'll have to do few assumptions. So the assumption statement goes like, consider the current I flowing through the resistance R, let the potential difference be V, let the charge be Q and the time T. Okay, this you can write it in your own words, no need to by heart it as it is. Just remember all the terms which you'll be using to derive the formula must be mentioned. Now after that, the work done on the charge Q will be V into Q. Okay, the work done on charge Q having potential difference V is V into Q. We have seen this previously. Then the source must supply equal energy when to VQ in time t. Next, moving ahead, this is the basic circuit we'll have to draw. So you all can see we have connected a resistor, then a voltmeter in parallel, ammeter in series, and a cell and a switch or a key. Next, power formula we'll be applying first. So this is the first step of your derivation. Power is nothing but work upon time. Perfect. Power is work by time. Then P is W by T. Now, moving ahead, why we wrote about work is to substitute the values of V into Q instead of W. So now we can write V into Q upon T. Why so? Because W is V into Q. Next, we all know that Q upon T is nothing but current I. So I get a formula, power is V into I, because Q upon T is I. So this is my first half of the derivation. Now in the second half we will be seeing about energy. So everyone, whenever we find out energy, we say energy is nothing but power into time. So this is the basic formula for energy. Now over here we are going to focus on heat energy. That is why we will be writing H. So H will be power P into time T. Now the equation number 1 where I found the formula for power, I'll be substituting over here. So I will get H will be V into I into T. So after combining this equation 1 and 2, I get the formula H is V into I into T. Now, again going back to our Ohm's law. In Ohm's law, we studied that V is I into R. So I'll be substituting I into R in this above equation and I get H is IR into I into T. Whereas I can say H is I square R T. So this is nothing but known as Joule's law of heating. So a very commonly asked question, what is Joule's law of heating? And derive the formula for Joule's law of heating. Or else they can also ask the factors on which heating effect depends on. So these are the three factors. One is I, that is current, R, that is resistance, and T, that is time. Moving to the last concept of this chapter, that is electric power. Now, power, as we saw, power is nothing but work upon time. That is why we say power is rate of doing work. As I told you previously, rate of means we divide by time. So, power becomes work upon time. P is W by T. So, work is also given as V into I into T. So V into I into T, now TT will get cancelled and we get a formula for power, that is power is VI. This is one of the formula for power which we can use. Secondly, we can also use one more formula where we can substitute W as V square into T upon R. Now over here V square into T upon R is nothing but W. Now we can see that TT will get cancelled and we get power ka formula as V square upon R. Next, moving ahead, P is equal to W upon T again and I square RT upon T. So TT gets cancelled and next formula which we get is P is I square R. So these are the three formulas with which you can find out power. So if you have potential difference and current, power will be VI. If you have potential difference and resistance, power will be V square upon R. And if you have current and resistance, power will be I square into R. So SI unit of power is nothing but watt, named after James Watt and represented by capital W. As we all know, watt is a very small unit. Therefore, the biggest or bigger unit for it will be kilowatt. And the commercial unit for power, the commercial unit which we generally use and which we get on our electricity bills is kilowatt hour, kWh. How many kilowatts you used hourly? kWh, kilowatt hour. So conversion of kilowatt hour into joules is a very important term which you'll have to remember. That is 3.6 into 10 to the power 6 joules. This will cover all our concepts, all our topics of this chapter. As promised, now we are at the end of this chapter. So at the end, I will be giving you all the important formula and the terms. So without wasting our time, let's dive into it. So the important terms are given below and their SI units are also given below. So quantity, symbol and their SI units. Moving ahead, a very important point to remember is the commercial unit. Commercial unit, kilowatt hour, is also known as a unit. So whenever they ask you a unit is nothing but a commercial unit. And whenever they ask you total energy consumed or energy used in the numericals, you'll have to first convert them into commercial unit. I have divided the formula list into three types. First is the basic formula list, where you can see all the basic formulas are used. Whereas the second one contains Ohm's law and resistance formula along with resistivity. And the last list contains the formulas for power and heating effect. This ends our chapter over here, and hope you'll be doing good in your exam on 20th. Just go through the video, revise regularly, and rock the paper. Aag laga do. Thank you.